Alright, geometry. Here we go, walking through. This is the chapter like 10 through 12 stuff. Again, I just picked out a couple of them to try to help you understand. So looking at something like this, they give you a bunch of numbers, labeling kind of around this shape. Okay, so what I want to do with you guys is I'm going to like blow this up here. Okay, we're going to put this on this page again, just a little bit bigger for us to deal with. Okay, so it says you have kind of this circle, and then it's kind of inside this polygon, and they tell you a bunch of things like this is 10 here, this is 9, this is this is 13. I don't know what that one is. And UV is, this entire thing is 16, and the entire SU is 17. And the rule to remember is that anytime a point is on two tangents, or two tangents meet at a point, that point is the same distance on both sides, or it's the same distance from the point of tangency on both sides. So if the right is 10, over here is 10. And if this is 9, this is 9. If this is 13, this is 13. And if this whole thing is 16, this is 3, which means that this is 3, which means this is 14 and 14. So in order to find the perimeter, all you're doing is adding together 24 plus 19 plus 22 plus 16 plus 17. Adding those all together, and you get your answer. I'm going to trust that you guys, again, could do all the math on some of these just to save ourselves time as you work through, okay? So this one, really simple. It's just remembering a rule that if you have a circle and a tangent, okay, that the tangent is perpendicular to the radius at the point of tangency. So the answer that's wrong is D. It says which statement is not true, because they're saying that angle should be obtuse in the picture. And they actually made it to look like it's obtuse right here. But you need to know that it's a right angle. All right? This one. I'm not going to solve this entire thing, but just suffice it to say two things. Number one, they're basically asking you for a radius. That means I could draw a radius anywhere, and that's what they're asking for. So the one I want is this one. It's going to make a nice little right triangle. And the other thing is that anytime you have a chord, like we have here, and it's perpendicular to the diameter, or part of the diameter, that the diameter cuts it in half. So if the whole thing is 12, this is 6 and 3. So you would do the Pythagorean theorem in order to solve for the hypotenuse. Right, I believe, sorry, by the way, I think these are off a little bit. This is that last one was number 10. Okay, this one's number 15. Number 15, and I think there's one after this also. You have a bunch of lines, and they're talking about angles. So there was 3 relationships we needed to know. If you have 2 lines that meet inside the circle, but not at the center. If you have 2 lines that meet on the circle, and if you have 2 lines that meet outside, and they could meet in different ways. This was one of the pictures. There was 2 other ones, so we'll just do this one for now. Okay, if they meet outside. So if they meet inside the circle, you're going to add your arcs together and divide by 2. I'm way simplifying this, trusting that you guys can go back and look at some of these things. If they meet on the circle, you just divide by 2. And if they meet outside the circle, you subtract and divide by 2. Okay? And basically the way in which you do that is you're taking like this arc here and this arc here, you're adding those and dividing by 2 to find these angles. This one, you take this arc and divide by 2 to find that angle. And this one, you take the big one over here minus the small one here, divide by 2 and you get that one. This is the picture we have here. So what I need in order to solve this is DEF, which this guy right here is 94. And I need this one inside here, which is B or HAB, which is 16. And they want me to find this angle here. So I'm just going to take those at 94 minus 16 divided by 2, and that will give me my answer. Okay. Again, I'm going to trust that you guys could do the calculations on this and leave it to you for sake of time in the video. But that's the one, because it's this picture. We're going to subtract, divide by 2. Just to throw it out there really quick, sometimes they gave you like an x here. So this would be like x, and they would give you this number. You're still plugging in, you're just setting it equal to whatever the angle was. So if I gave you the angle, the x would go here, and then the angle would go here. You're just solving algebraically. All right, this one is kind of similar idea, but it's for segments. So now we had some other pictures. It was like, if I actually do this in black here. Okay, if I have a circle with two lines that are intersecting, you've got this guy here and this guy here. You take the two blue ones, I'm going to call them A and B, and you multiply those together. And you should set those equal to the two red ones. We'll call them C and D. And those are equal to each other. So that was one. We had another one. What if they meet outside, like this? Again, I got to color this a little bit. And this, something like this. So you would have A here and B here. And then, actually, let me just be consistent with my colors. And that'll make things actually a lot easier for us. C here and D here. So same formula, it's just set up slightly different. And then the last one has its own formula. That one is a little different. That's this picture here. It looks like this. So anytime they meet, one line goes outside. All right, I'll just use a completely different color for this one, yellow and green here. One of them, though, only goes in, like, it doesn't go in. It just touches the outside. This is a tangent line. Okay. If you remember, all these other lines are called secants because they touch the circle 2 times. One here, one here. So this one, you're going to do something similar to what we did over there. We'll call it X here, Y here. And then this one is Z. So you're going to do Z squared equals X times Y. Okay. So in this case, you've got Z is 22, and BC, they tell us, is 18. All right, and then I don't know if they tell us something else. They want us to find the diameter. So they want you to find, in this case, like this entire thing, which I'm going to call this. I want to be careful. It's not the same X as that, but I'm going to call it X. Okay. So what I would have on this problem, my setup would be as follows. I would have 22 squared equals, and then I would have 18, that's my X, and then Y, which is this entire thing, is 18 plus X. Okay, so solving that out, what I would have is 484 equals 324 plus 18x. And I'll leave you to solve that out after that one. You just kind of subtract the 324, divide by 18. All right, next one, we've got these two shapes. So the ratio of the side lengths. The ratio of the side lengths is 4 to 9. So this is the ratio of the the side lengths, small to large. And then the area of the small hexagon is 16. They want the area of the big one. Okay. What we need to remember is that the scale factor of the sides is not equal to the scale factor of the area. You actually have to square these values in order to get that. So if I square 14, I get 16. And if I square 9, I get 81. And so this ratio is the same as the ratio of the areas. Okay, this is the ratio or the scale factor for the sides. You square those to get the areas. Okay, if this was volume, I would cube them. All right, three-dimensional shapes, right? And then I don't really need to cross multiply here because if the tops are the same, the bottoms have to be the same. It's kind of easy. All right, 35. Okay, this one, it tells you that you have the area of this kind of big shape, and they want to know how much it's in the square that's not taken by the circles. This is a really good example. Like, hey, let's say I had some cookie dough, I rolled it out, and then I cut out a bunch of circles. There's some left over. I want to know, can I make any more cookies, right? That's what I'm looking at here. We want to know what's left over. So if each radius is 2, each diameter is 4. So look at this, think of it as this way. You have 4, 8, 12. Okay? So this is 12. So the area of the entire square is 12 times 12, which equals 144. Okay, I hate writing it that way. I'm going to write this 12 squared. Okay. And then what I'm going to do is I'm going to subtract the area of the circles. Well, each circle, if I just take one circle, again, if it has a radius of 2, that's pi times 2 squared, or 4 pi. And there's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 times 9. So that's going to equal 36 pi. You can see where we're going here, that this is our answer. You're going to take the square, you're taking out all those circles, so you find out what you're left with. And they wanted the answer in terms of pi, so we leave it that way. All right, this one. 2 things you would need to know is the area of a sector. I don't think I included, I think 37 actually asked you just for the area of a sector. So the area of a sector and the area of a triangle. So what we're going to do is the area of the sector, which is this guy right here. All right. It is the central angle, which is 90 in this case, divided by 360 times pi r squared. The radius is the square root of 2. Which is equal to, if I square this, you have 2. So it's 90 over 360 is 1 over 4. Times pi times 2. Oh, these are going to cancel out, so I have pi divided by 2. And then the area of the triangle, since it's a right triangle, I would just do 1/2 base times height, right? 1/2 base times height. And the base and the height are the legs, which are both radii. So the square root of 2 times the square root of 2. And we actually just looked at this kind of a second ago. The square root of 2 squared is 2, divided by 2 is 1. So I'm going to subtract 1 from that. That will be my answer. Okay, you can see C is what we're looking at. All right, this one, I just want to make sure they're talking about the idea. So you've got a box shown is a candy container with a square base, pyramid top. How many square inches of pasteboard are needed to make the box? Not counting the overlapping edges. So the idea is you have a pyramid and you have a, not a cube, a rectangular prism, and they are overlapping in some way. So if I took my formulas for a pyramid, it would be 1/2 perimeter times slant height plus area of the base. And if I took the, change this really quick, change the color. Make that blue. And then if I take the area of my rectangular prism, perimeter times height plus 2b, okay? Again, that would be like all of this stuff. All right, and the blue would be all of this stuff. And what ends up happening if I did that is I would end up counting 3 bases. There's 2 bases right now, though, that are not involved or hidden. There's 2 of them right here. Okay, I want to make sure you see that there's 2. There's 1 here and then 1 of these. I don't want both of those, okay? I only want the one on the very bottom. So if this is kind of my formula, and what I would do is basically add them together, all that matters is I don't want the 2 bases that are inside here. It doesn't matter where you take them away from. So what I'm going to do is I'm going to take them away from right here. I need to get rid of 2 bases. That's a really easy way for me to do that. Okay, so let's get rid of that. And then I'm just going to plug into my formula. Everything else works the same. So really nice. You have 1/2 the perimeter of the base is 16. 4 plus 4 plus 4 plus 4. The slant height is 4. The area of the base is the area of any of these bases. They're all squares, so 4 times 4 is 16. Plus the perimeter, which was the same as over here. And then the height of my box is 3. Okay. Again, I think I'm going to let you guys kind of multiply this out. I think you're fine really quick. We'll just do this because that's really simple. All right, so you end up having a total of 2, 3, 4, 5, 6. 16 times 6. Multiply those out, you should get your answer. All right. This one, mechanist drilled a cone hole into a cube of metal as shown if the cube has side lengths of 8. So all of these are 8. What is the volume of the metal after the hole is drilled? Okay, so what we're going to do is find volume. Volume of a cube is 8 cubed. The volume of a cone, notice a couple things, that the radius would be 4, the height would be 8. So we're going to subtract 1/3 pi times the radius 4 squared. Okay, and you just kind of, again, punch that through on your calculator, you'll get your answer. All right, you're subtracting. This is not a surface area question. That would be a little more detailed, a little trickier. You'd have to think through what do I include and what I don't. But volume is a little simpler. You just subtract or add them together. All right. So hopefully this is helpful. Not crazy short. Not crazy long. But hopefully that's helpful for you understanding the big picture of the last couple chapters.